Hello guys, in this video I'm going to show you how to solve Bitonic array maximum. So let's dive right in. Okay, find the maximum value in a given Bitonic array. So what is Bitonic array? An array is considered Bitonic if it is monotonically increasing and then monotonically decreasing. Monotonically increasing or decreasing means that for any index I in the array, the number at index I is different than its next one. Its next on the right at index I plus 1. Okay. So for example, with this given input, you can see there are two parts in this array, right? As you can see here, it first monotonically increasing and then monotonically decreasing. So 0, 1, sorry, 1, 3, 8, 12. As you can see, it is increasing until 12 and suddenly it start decreasing since 12. So 12, 4, 2. So the maximum values is just the cross point between increasing and decreasing, right? So the cross point between two parts of the array, right? So our goal is to find this uh, this maximum number, right? So how we can solve it? Actually, our even though it is it is even though there are two parts in this array, but um, it still can be considered as a sorted array. In some sense, it's still sorted, right? It is sorted in the first part, and it is sorted in the first part in ascending order, and it is also sorted in the second part in a descending order. So because it is sorted, so we can think of the binary search, right? So we may use this because firstly it's sorted, right? Secondly is that we must find a specific number, right? In this case the maximum one in the array. So let's try to run through it manually here. So here is our array, right? And this line is just the index of every number. So for finding such, I'm gonna start with 2 pointers, left and right. Left is left pointer points to the first number, and right pointer points to the last number. So it is represented by these curly braces, right? Okay, we start from here, right? Assuming that we don't know the where is the crossing point yet. So what if what if we find the middle numbers, right? The middle one in this case is let's say is 5 here, so 5 divided by 2 is 2.5. It round down to 2, so here will be the middle one, right? So um, there's an observation here that we can make, which is this middle number can only be either in the decreasing part or in the um, increasing part or decreasing part, right? Or if it is in both part, it means it is itself is a cross point and also the maximum number. So uh, what if it is let's say let's write down case one, middle in increasing uh, part, actual middle in decreasing part. Okay, 3 middle in both. So this guy middle is marked, right? But if it is increasing part here, what does it mean? Uh, but first, how do we know that the middle is in decreasing part or increasing part or decreasing part? So one way we can know that it is to compare with its next number, right? We can compare with its next number on the right, which means I'm gonna compare the array at middle with versus array dot middle plus one, and middle in the increasing part. It is when uh, this one is less than the number right next to it on the right to the right, right? So it's less than. There's no case that there's not any case that these two are equal, because here there's a restrictions in the problem statement here. Two number that is next to each other will different. And here is one case. So if the numbers is on the middle is on decreasing part, what does it mean? It means that we can further limit our range, because now the middle is on increasing part, so the maximum number will be for sure on the right of the current number, right? Of the middle one. So that we can eliminate a half of the input space, which is really nice. Marks on the right of middle. Okay, exclusively mean not including the middle, because here middle is less than is right, so the maximum can be um, ranges from middle plus one till current right, and this is one case, right? Middle in the decreasing part. How do we know the middle is in decreasing part? The number of middle in the decreasing part when the it is actually the reverse of the above conditions, which is array of middle is greater than array dot middle at middle plus one, right? So it like this. So it means, what does it mean? If the middle is in the decreasing part, it means the maximum will be on the left of the middle. Here is exclusive marks on the left of the middle. Okay, on the left of the middle. Or uh, can the middle is the maximum one? It can be because um, currently we are comparing the middle with the number next to it on the right, right? So it can be the case that the current number is the maximum one and the number on its right is the second number in the decreasing part, right? So here max is on the left of the middle but inclusive, and will mm, it will include this case, right, as well, which is middle is in both. Middle is max, right? So in general, we have only two cases here. Okay, let's try to uh, code it out so that we can really understand it. Uh, we use binary search. We need two pointer left and right. Left will start from 0, right will be the last index, which is array length -1. Uh, wanna run into a loop trying to um, trying to for each iteration we want to eliminate half of the search space, current search space. Okay, so what is the conditions that we want to get into the loop here? Is it left less than right or less than or equal to right? Uh, let's say less than or equal to right, but we can update it later. So because okay, so we need to find the middle index, right? Uh, to find the middle index, easy. It would be not a floor. Inside, I will take left plus right minus left divided by 2 plus left. Okay, and round down, and we can get the middle index here. The next thing that we want to do here is to um, we want to know that whether the middle is in the increasing part or it is in decreasing part, so that we can limit our search space by half, right? So in order to know where the middle is in the increasing part or decreasing part, we can compare it, the number middle index, with the number middle plus 1. If it's less than its right, its number, the number on the right, it means the middle is in increasing part. So um, it means the maximum is on the right exclusively. So it means I will reassign, update the left. It will be middle plus one, right? Exclusively, so we don't want to take the middle. But if this is not true, it means else here. Uh, it means array at middle is greater than array middle plus one. There's no case these two are equal because we know that for sure from this statement. So if it uh, if it get into this uh, it this block, it means, what does it means? It means that the middle is in the decreasing part for sure, but it can be the case that it is the crossing part, which is the um, largest number in decreasing part, right? So here we can, what does it mean here is that the maximum number can be the current number or uh, can be any numbers on the left side, right? So we eliminate the right side. So in this case it would be, because we want to take the left inclusively, so I will reassign the right to middle, right? We want to take the middle because the middle can be the maximum. Okay, so probably here we want to exit when left equal to right, right? So when left equal to right, it means the current number is the left equal to right, and the middle is also equal to left and right. So it is when the middle will be the maximum number of the right. So here the conditions, I will update the condition so that we can keep searching is left less than right. So if left equal to right and also equal to middle, I'm going to exit the loop and return the maximum number. Alright, at left or right, either will be fine. Okay, I'm going to test just 9, no, 11, 6. Okay, it works perfectly fine. Just double check. Okay, awesome. So that is it for Bitonic array maximum. And yeah, thanks for watching. See you in the next video.